Hello everybody and welcome to the best session that you will see at the Hybrid World Adelaide Tech Conference. I am completely biased because this is my absolute favourite thing. We're going to talk about space. Now, Adelaide, you may or may not be aware of this, but it has become a global centre for privatised space innovation. And this session is going to bring together some of the leading minds in the Australian space industry to discuss the possibilities and potential in the field. Now, the concept of the adjacent possible was introduced by biologist Stuart Kauffman in 2002 to describe how life forms combine and recombine into more complex organisms. The concept was later modified by author Stephen Johnson in his book Where Good Ideas Come From to describe how novel insights in one field can spur breakthroughs in others. Now, today we stand on the brink of another kind of adjacent possible by combining new technologies for space exploration with terrestrial systems. So all of that is to say that space is awesome and it can benefit us here on Earth. We're going to hear from some people today to explain exactly how. Now, our first speaker today, we are very lucky to have her as a special guest. We have Dr. Christyl Johnson, who is the Deputy Director for Technology and Research Investments at NASA's Goddard Space Flight Center. And she's going to share the vision that NASA and its international partners have for the journey to the moon, Mars, and beyond, and the ways that NASA is transferring its innovative technologies to enable commercial opportunities in space, but also in health and medicine, transportation, public safety, energy environment, and industrial productivity. So we have a lot to learn. Please welcome Dr. Christyl Johnson to the stage.
Well, hello there. All right, we're getting started here before lunch. So thank you very much, Ray, for that introduction. It is truly my pleasure, an honor for me to be here with you today as we highlight some of the transformative technologies that we have developed that you're actually enjoying every single day in your lives, and the transformative technologies that we're developing right now that are going to fundamentally change the way you think about the way you're living today for tomorrow. So, I am from Goddard Space Flight Center. I'm gonna see if I can click right. No. I am from Goddard Space Flight Center. Can we forward? There we go. From Goddard Space Flight Center, and at my facility, we are the largest science center. There are 10 different facilities, centers at NASA. And I'm at the one that is the largest for all of the science missions. We have about 10,000 employees at my facility, and those 10,000 employees are all in some way or another focused on creating the missions of the future and designing and executing the missions of the future in astrophysics, earth science, heliophysics, which is the study of the sun, planetary science, and then we've got 4 additional lines of business where we're making investments that are cross-cutting in nature, that are focused on communication and navigation, cross-cutting where the cross-cutting technologies are really focused on accelerating those technologies that are going to be needed for those missions, and also miniaturization of technologies and whole systems, and other things that there's no business case in private industry to do, so we take those on within the federal government. Suborbital platforms, which is where we're able to actually do balloon campaigns and aircraft campaigns and sounding rocket launches with the small sats and universities. And also human exploration and operations. We're developing technologies that are going to be supporting human exploration in the future. The only mission area within NASA that we don't have work and research going on at Goddard Space Flight Center is in aeronautics research and development. So if you look at this is the portfolio that we have. We have been very, very fortunate at Goddard alone to have over 300 successful missions that are flying right now. And we're doing on-orbit operations for many of them. As you'll see, they're in all 4 of those core areas that I explained to you as our 4 core lines of business. One thing that I wanted to just point out to you is that success at NASA is not just measured by the data that comes back from these spacecraft and the missions that we're actually executing. Success is measured more in being able to take those technologies and the data that comes back and transferring it to improve the quality of life for everyone. And so when I say to you all, NASA, what is the image that comes to your mind when you think about NASA? It's probably these things behind me. It's probably an astronaut in a spacesuit. It's probably people floating around in a gravity-free environment on the International Space Station. But one of the things that I want to do today is to kind of shift the way that you think about NASA the next time that comes up when you leave this room. I want you to kind of skew your view when you think about NASA, because NASA is actually contributing to every single day in ways that you probably don't even realize. And so I want you to understand that as you develop this space agency, which Australia has decided that they're going to do, I'm really excited about it, and the whole community gets excited when we have new players coming to the table, new partners that we can work with, new companies that are going to be spurred to innovate to help achieve these global visions and goals. And so when you do your space agency, you'll be seeing the types of technologies and innovations that occur that you're not even thinking about when you're trying to solve your important missions. And so we have impacted your lives in consumer goods, environmental and resource management, public safety, transportation, health and medicine, and computer technology. When you think about consumer goods, is there anybody out there right now that has a programmable oven? You have a programmable oven. All right. So the command and control capability that we established for the International Space Station to operate remotely is now being used because a gentleman came up to some of us at Glenn Research Center and said, you know what, I need to eat more healthy food. I need to be able to cook at home instead of always going out to eat. But the problem is, I work so late in the day. And by the time I get home, there's no time for me to actually cook meals. So isn't there some kind of way that somehow we can come up with an oven that's a cold and hot combination? You can actually take your food out of the refrigerator, you prepare your food on the weekend, you stick it in the oven before you go to work, and it's a refrigerator, so it keeps it nice and cool for you. Then when you get ready to leave work, you take your phone out and you program, okay, I'm ready to start, and the food cooks while you're on your way home. If it takes you a long time to get home, it transitions into warm mode to keep the food warm for you. When you get home, you pull it out and put it right on the table and actually conserve your food. And so that gentleman came to our researchers. We worked with the folks from the International Space Station and a private industry company that was working on ovens. And now today, that technology has been transformed, and you can actually purchase one of these in the United States, and they work constantly. Also, the physiologists that have been working with monitoring the health and welfare of the astronauts on the International Space Station have been working with these private industry companies that do biometric measuring and reading out. And so we've transferred that technology for wearable biometric devices that many of you use for sports today. That also came from research that we were doing at NASA. And many of you probably know of the company Speedo. Have you heard of the company Speedo? They do swimsuits. And so Speedo came to NASA and said, for our Langley Research Center, you guys are doing a lot of drag and friction reduction in your wind tunnels, looking at how do you reduce the drag and friction for your aircraft. Can you help us design a swimsuit that would actually help to reduce the drag for swimming? And so our scientists said, sure, let's get together and work on this. Well, we did, and we came up with the LZR Racer. And 1 month after that was actually put on the market, there were 13 world records that fell in that next Olympics, and that was only 1 month after it came to market. You don't think about things like a swimsuit and coming to NASA to help you design your swimsuit, but we work in partnership with everyone who has a really good idea, that has technology, can use the technology that we've been developing at NASA. If you think about energy and the environment, the solar and wind capability that we developed so that we can have extended stays on Mars, we really weren't even thinking about that when it comes to bringing it back to Earth and using it in places where you have extreme weather conditions like you have on Mars, like the North Pole. And so the technology that we developed for that is now being used in wind turbines in the North Pole that they're able to withstand extreme temperature requirements, and it's been saving a ton of money for them because they're doing solar and wind power generation as opposed to the electric. In addition to that, we designed these algorithms so that we could map the stars and know exactly where they were. Who knew at the time that we would be asked to help the scientists say, how do we track these rare animals under the water? Come to find out, whale sharks and polar bears, the spots on them, the spots on the nose of the polar bear and the spots on the sharks are as unique to them as our fingerprints are to us. So if we are able to see them from there, we can actually track these rare animals under the water. Who would have thought it? But it's happening. And in public safety, we have these carbon nanomesh technology that can actually filter out 99% of all bacteria and viruses and all chemical compounds in water. And so we're taking that carbon nanomesh system, putting it into water filtration systems, and now we're able to provide clean water in very, very remote systems just using a very simple technology that we had to develop for NASA. And then Robert, in his presentation yesterday, talked about ingestible detectors or sensors. These digestible thermometers are being used. We had to use those so that we could monitor the health of our astronauts in flight. We had to make sure that their body temperatures were going to be regulated because they're under so much extreme pressure when you have all of that thrust going up into the International Space Station. We've transferred that working with doctors and companies in private industry. So now in the National Football League in the United States, all of the football teams are using this so that they can prevent the heat strokes and the other illnesses that come from working in these hard sports out in the heat for many hours that they do. And so that's been very beneficial for them. And this particular one is our search and rescue technology that we developed, because sometimes you'll have one situation where you'll have a not so wonderful return back into the Earth's atmosphere. We've had a few accidents in the United States, and now we do everything in our power to prevent having the same mistake twice, and everything in our power to prevent loss of lives for our astronauts. So we wanted to make sure that if we have one of those kind of bad days, we could actually retrieve those astronauts wherever they are on the planet. And so with this search and rescue device, it's just a little handheld device, if you can get one single signal pulse out of that thing, and we can pick it up from just 4 satellites up in space, we can find you anywhere in the world that you are. And so we sell this. We worked with a company to sell this commercially, and now people who have their private planes are using it in their planes. People who go out in their boats are using these tracking devices, and people who like to hike in the outback and any type of brush areas are taking this with them, and we have saved thousands, tens of thousands of lives finding people when they've been lost with this tracking device. And in the area of transportation even, we had to come up with a formula that would allow aircraft to actually not have ice stick to them so that we could actually prevent them from coming down. And so this de-icing material that we developed, we transferred it to another company that transitioned the formula just a little bit and applied it to the train tracks and to the switches on tracks so that you can actually prevent delays in the train system. And that has been very, very beneficial. One other thing, for the International Space Station, you know there's space junk that flies around, and sometimes something could actually impact the International Space Station. If there's a hole or if there's any kind of detriment that happens up there, you gotta have a quick patch that you can go out there and repair. And it would be great if it could be replaceable, because you might have to take it off and put another one back on or whatever. And so we had to create that kind of device, and now it's been transferred to the race car industry. And they're using those quick patches whenever they have these accidents in race car industry. And as we think about health and medicine, and this is the area that is the richest when it comes to the technologies that we are transferring, and it happens every single day. People are approaching us with their problems, and we're working with them to solve them. So we came up with these algorithms and techniques that we had to use to measure the curvature of the James Webb Space Telescope mirrors. And we took those very algorithms and worked with a private company to be able to transition those to be able to map the entire eye in a way that's so quick that your doctor's visit is very, very short. They can do a complete scan of your eye and look for things, early detection of cataract and other illnesses in the eye. So it's improved those kind of measurements significantly. Also, we had some of our researchers work with 2 doctors that came to us, and they said, we really need a way to kind of prolong the life of some of the people who are waiting for these heart transplants. Can you help us come up with a very unique cardiac pump that can actually work for this? And because of the research that we had already been conducting, those 2 doctors worked with our engineers and a private company to create this cardiac pump, which now saves lives while they're waiting for the heart transplant to happen. And for ultrasound, we have had to develop ways to do quick ultrasound and quick measurement of ultrasound techniques for our astronauts on the International Space Station. We worked to transfer that so that we could develop portable ultrasound systems. And they're being used like at the Olympics when you see people have these ski accidents and other things. They're doing a quick portable look at it. And with telepresence, they're able to bring in doctors from their home organization, their home state, so that they can actually analyze, assess what's going on with the athletes real time and near real time transfer with the doctors on the ground so that they can keep on moving and get the results in that they need. And let's not forget the arts. So for NASA, the A, which is the arts and STEM, science, technology, engineering, the arts and math, is very, very important. Because for us, it doesn't do any good for you to just be an excellent engineer or for you to be an amazing scientist. We need for you to be a whole person, which enables you to bring all of yourself to the table. And that means being able to communicate. I don't know how many of you know physicists or engineers that walk around and do this. They're looking at the ground and their phone and not really looking at other people, have a hard time communicating. And even if they come up with these amazing and ingenious ideas, they have a hard time communicating it to others so that they can translate it in ways that apply and make a difference in other ways. And so it's important for us to incorporate all of that into the training that we provide for our engineers. So one of the partnerships that we have established is working with the National Philharmonic in Washington, D.C., and with the New York Philharmonic in New York to come up with a completely multimedia production. And with that, the first one was the planets. So going to the symphony was amazing because you actually got a chance to see how the symphony, the musicians, interpreted the planets. And so they worked with our engineers to listen to some of the sounds that come back from satellites and to kind of work through digital presentations. So when you see a planet up there, you're hearing the musician's interpretation of that right there in the symphony. And it was absolutely mind-blowing. On top of that, when we talk about arts, it's not just the musical side of things, but also the film industry. That's something that's really important for us. And so I worked with the Hollywood Film Festival to establish the first Stargazers project. And what we were looking for is just help us come up with the next generation sci-fi feature film. We want your ideas for the next great movie. And so we put a call out to all the writers in the United States, and we said, give us your ideas. Do you have any cool things that you think you'd love to see on the screen, on the movie screen? And we had tons of people that submitted their ideas. We culled it down to the top 10, and those top 10 were invited to the film festival so that they could pitch their ideas to this panel of movie producers and writers and so forth and so on. And so the top 5 from that, we invited to come out to NASA and to work hand in hand with the scientists and engineers so that they could actually hone in and fine-tune their concepts for the next phase. And so it's exciting to get the whole community engaged in that. And one of the things we'd like to do is also engage the kids, because they come up with ideas, they don't know that something's not possible, and it helps you to even stretch the boundaries further. So what next? what does the future hold? What is it? What are the next things that we're going to be working on? And how can that actually impact the lives of all of us today? So what we're trying to do is go from Earth reliant to using the moon as a proving ground where we're going to test out technologies, we're going to hone our capabilities, and get ready for our trip to Mars. Because ultimately, what we're trying to do is put a human on the surface of Mars. And here again, every time you have an impossible mission, and this is truly impossible, there's no way that a human right now can get to Mars and survive once you get there. The radiation effects alone would kill them. We don't have a way right now to even protect them from the radiation. So there's a lot that has to be done in order for us to realize this impossible vision. But when you say impossible for NASA and for engineers, that's when we get excited, because we're going to prove to you that it is possible, and we'll show you the technologies that we're developing that will also transfer to new innovations and improving the quality of life that we're going to develop to get us there. So in order to do that, there's a stepping stone that we have to go through. In the middle there, you see this little tiny device, and that is a deep space gateway. We're going to be working in the international community to build this deep space gateway. And that's going to be pretty much like an international space station on steroids. This deep space gateway will be able to fly out to whatever the target is going to be, the destination will be. And there's going to be a little piece on the end up there, that's the transport unit. That piece will disconnect from the space station, from the deep space gateway, and go down to the surface of either the moon or Mars or wherever it's going to go, or even out to an asteroid that's coming close to Earth. Be able to take samples and then come back to the gateway and have the analysis done right there with astronauts, and those astronauts will be able to work with the astronauts or the scientists on the ground to be able to analyze what needs to be analyzed. And so, actually, as a part of that, the NASA partners, international community and all, will be looking for contributions in transportation elements, gateway capability, and this is little tiny technologies that will be able to contribute to that, like bathroom capability, breathing systems, and some of everything. Mission control centers will have to be in multiple places around the world. Launch facilities, and you all have some launch capability in Australia. Payload and experiments and operation centers will be necessary everywhere. And that's a part of the big global NASA mission. So how is it that we're going to get there? Well, as I said, we are going to be developing new technologies. And we're going to have to kind of shift the focus of our capabilities. So as you know, you have limited resources. You can't always continue to do things just because you've always done them. You really have to think about where is it that we're going, what capabilities are going to be needed to get us there, and then we have to kind of make a shift to be able to do that. And it's really hard to make shifts when you've got a really big ship and you're trying to change course on a big ship that's already got momentum going in another direction. And so that for us is also another creative challenge. But that's part of the reason that NASA has been chosen. We have to do these employee viewpoint surveys across the whole federal government in the United States. All the employees are mandatory for us to take these surveys. But NASA, at the end of all of this, comes out as the #1 place to work in the federal government for the past 6 years. And my facility, Goddard Space Flight Center, is the #1 of all the NASA centers, 10 NASA centers in the country. And so we are very good at kind of helping to reshift the focus area of our people. But STEAM leaders will have to be developed, and that means all the way through the pipeline. We're talking about K through 12, we're talking about college-age people, and we're talking about ways to improve the environment to encourage them, early career professionals, and getting more women engaged in STEM as well. And so in developing the STEAM leaders, we have a very comprehensive training program within NASA. And so that requires the scientists and engineers to engage with each other and work together. As I said, no more scientists sitting in the corner and playing in their own sandbox. And we're changing the operating model as an enterprise to focus on those new capabilities that I mentioned to you. But then we're also focused on the individual. So if someone wants to look at their individual capabilities and actually hone those, we provide specific training for that. And if their particular capability is not needed anymore, We pay to have them shift that training to focus in a new area that we know we're going to need within the agency. And I already mentioned how we're including the human arts, the arts and humanities as a part of everything we do, including project management and engineering. And so when you think about that, the technologies that we're talking about, we have a group of people right now working this Tiger team across the agency is looking at what kinds of technologies are going to be the premier technologies that we think will make revolutionary changes to the way we do business and to improve the quality of life. And these are the 9 right now that we are looking at. Advanced manufacturing in multiple ways, and that's materials and everything else. Advanced materials, separately from advanced manufacturing, artificial intelligence and machine learning, and you guys have been hearing about that quite a bit out here. Big data analytics, integrated photonics, miniaturized systems is going to be key. Power generation and energy systems, and quantum technology. And when I say quantum technology, I mean the full gamut of quantum technology, quantum communications, quantum sensors, and quantum, there are a whole bunch of different areas with that. So that, if you think about any one of these individually, it can make a revolutionary change. But if you combine them, like for instance, the artificial intelligence, the autonomy, miniaturized systems, and imagine what kinds of things will happen with that, and the quantum security pieces of it, you can envision things. If I just create something in the back of my head out of the blue, think about the missions of the future that we will be able to enable. If you look at that sun up there, if we have something like a coronal mass ejection, which is this plasma, big mass of plasma, magnetic plasma, that the sun just spits out, and it's like shooting a nuclear bomb down to the Earth, or like an EMP. So once it gets close to any other satellites, or once it gets back to the Earth, it's so powerful that it can knock the electric grid out and the whole east coast of the United States. Or it can knock out all of the power that you're experiencing here in South Australia. It's that kind of powerful stuff. So the heliophysics missions that we do at my center, and we're the only NASA center that really focuses on the sun, we are watching for that kind of thing to happen constantly so that we can warn everyone back down on Earth and all the GPS satellites and everything else, put yourselves in safe mode, or else you're going to be taken out by this coronal mass ejection that's happening. So you have a swarm of spacecraft, and some of your companies here are developing these small sats and CubeSats right now that we'll be able to use for this. The swarm looking at the solar, you have a group of satellites over here that are looking down at the Earth, measuring different storms that are coming. But imagine having a solar storm and another storm, an Earth storm going on at the same time, and the impacts that you can have on that, major tidal waves that are going to be swarming, that'll swoop over many parts of the world. And then on top of that, we've got all these asteroids that are floating around out there. And imagine one is coming towards the Earth that we need to know about, and we need to be able to send commands to the military to say, you got to do something to move that. When you have these coronal mass ejections, the magnetic field can actually push these asteroids away from us and help to protect us. But if you have these kind of systems and you've got a reconfigurable constellation out there, you can have one move to take a look at something else and then move to do something else. It will totally change the way that we can protect our Earth and our lifestyles right down here on Earth. And the great thing about quantum communication is information that goes from one set of satellites to another, you actually have to have a key, either on the sender side or the receiver side, in order to be able to hear or to pick up the data, and you can't make any changes to it. So it's secure communication. You don't have to worry about an enemy who wants to do hazardous things to us and being able to take that information and change it so that we're doing harmful things to ourselves, not even knowing it. So it's important, all of these technologies, to continue the quality of life that we're all enjoying on this Earth. And NASA doesn't even try to do this kind of stuff on our own. We thrive on our international partnerships. And right now, we have over 818 active international partnerships. If you look down here in this corner, we have 33 already with Australia and New Zealand. And so those are active agreements that we're looking right now to make improvements in and stand up new agreements. And examples of those range from large multilateral programs to education and outreach activity that we want to partner with you on. I've been having conversations with government officials here in South Australia so that we can have these international internship programs to be able to work, have the researchers and students here to be able to come and spend a year maybe on the ground at Goddard Space Flight Center, working with our engineers and scientists to be able to produce papers and work that learn some of the technologies and capabilities as students and be able to bring them back here and make significant improvements in what they're doing in the labs here. And ground-based networks are a part of this, and applied sciences. Multiple areas, and I don't expect you to read this, but I just wanted you to see right now the current ones that are here. I'll be leaving this chart with you. University of South Wales, University of Queensland, Curtin University Technology, Woodside Engineering Technologies, Victorian Space Science Education Center. There are tons, and they're in multiple areas. And as I mentioned to you before when I talked about transferring technology, we're here also to work with you to solve problems, to solve challenges that you have. And we love being able to be brought these difficult problems and help you to solve those problems. For this next chart, you might want to just get out your phone and just take a picture unless you are write really fast, but I wanted you to know, for those startup companies here that are looking for technologies to be able to transfer into commercial products, we have a full listing of NASA patents and software at technology.nasa.gov. We have quick launch licensing, so we have select technologies for rapid development at this particular website. And then we have more examples of the spin-off examples like I mentioned to you today and showed you up here at the spin-off website. And then we give you a free monthly catalog of all of the NASA engineering and design concepts at this particular Tech Brief website. So we are open for business, we're open for partnerships, we're looking for more areas to work with all of you, and we're excited. I'm excited to be here today, so thank you for your attention.
Thank you so much, Dr. Christyl Johnston. Let's hear it again. It's amazing when you hear someone talk and you look at a bunch of things that you're like, no, that couldn't possibly be real. But it is. And it's awesome. Spacecraft constellations, seriously? Our next speaker is Dr. Paddy Newman, who is the co-founder of Newman Space. And he's going to have a bit of a chat to us about Space Missions 101. What you need, how to get them, and why do we do it at all? Please welcome.